today we're going to be doing lesson 10, solving algebra word problems part 2. And we're going to go through those 4 steps. Remember, the first one is you need to write your let statement, then your algebra equation, then use algebra to solve, and step 4, the last step, is your therefore statement. Example 1 says, one number is 5 times another number. The sum of the two numbers is 132. Find the two numbers. So the key things here is that one number is 5 times another, and that the sum is 132. They want us to find the two numbers. So my first let statement is going to be let x be the first number. And then the second step is I'm going to use the information from that first part. One number is 5 times another number. So 5x is going to be my second number. So I'm done step 1. I've written my let statements. Step 2, I have to write down my algebra equation. Up here it said the sum of the two numbers, and now sum means I'm going to add them. So the sum of my two numbers, I'm going to add them, is 132. So the sum of two things is 132. The first thing was x, the second thing was 5x, and that equals 132. I'm going to use algebra to solve. So x plus 5x means I have 6 x's, and that equals 132. And I have 132 divided by 6, because I have to divide one side by 6. Whatever you do to one side, you have to do to the other. And I get that x equals 132 divided by 6, 22. So x equals 22, but I'm going to write that in blue. X equals 22. Now the last step is to go back and make sure that I answer the question with my therefore statement. It asked us, find the two numbers. So therefore, the two numbers are, well, we figured out that the first one was 22, and then the second one is 5 times as much. So 22 times 5, that's going to give me 110. So that's the second number. Or I could have subtracted that 22 from 110. That's the first one. If you're a bit confused, hit pause, go back, read through it again. Maybe try writing it out on your own. Example 2. Jason bought 6 new baseball trading cards to add to his collection. The next day, his dog ate half of his collection. Now there's only 34 cards left. How many cards did Jason start with? My let statement's going to come from the final part. How many cards did Jason start with? Let x be the number of cards Jason started with. That was step 1. Step 2 is to write the equation, and it said Jason bought 6 new baseball trading cards to add, and then the next day dog ate half, and now only 34 cards. So let's go back. Now only 34 cards. It's going to equal 34, whatever we're doing. So we started off with a certain number of cards. Then he bought 6 new trading cards to add. So I'm going to add 6. And the dog came along and ate half his collection. So I'm going to take that whole collection, put it inside brackets, and I'm going to divide it by 2, because that's the same as cutting something in half, dividing it by 2. And now I'm going to use algebra to solve. I'm going to get rid of that divide by 2 first, so times 2 to both sides. I'm going to be left with x plus 6 equals 68. Then I'm going to subtract 6 from both sides, and I get that x equals 62. And that was all part of step 3. Step 4, answer what was asked. How many cards did Jason start with? Therefore, Jason started with 62 cards. And that's example 2. Moving on to example 3. The width of a rectangle is 1/3 of the length. That's going to be important. The difference between the length and the width is 18 meters. If you double the width and increase it by the length, the result will be 45 meters. I'm guessing that's important. And maybe this thing about the difference too. Let's see. So it's asking us to find the dimensions of the rectangle, and I'm going to use that to make my let statement. So my first let statement, let x be the width. Remember, I always choose x to be smaller, shorter, or younger. It's always easier to add and subtract than multiply and divide. Choose x to be smaller, younger, or shorter. So the width is definitely shorter. The width of a rectangle is 1/3 of the length. So the width is definitely shorter, and it's 3 times shorter. If it's 1/3, that means the length is 3 times as big as the width. So let 3x be the length. Now we need to write our algebra equation. One way we could do it is to say that the difference between the length and the width, oh, there's a typo, and the width is 18. Let's try that. Let's try using this one here. The difference between the length and the width is 18. Difference means we're going to subtract. So the difference is 18 meters. We don't need the meters until the end. 18. So difference means I'm going to subtract. So I'm going to subtract the small thing from the big thing. I'm going to get 2x equals 18. Now I'm going to use algebra to solve. Divide by 2 on both sides, and we get x equals 9. Let's check. Oh, that was step 3. Let's just check that. I'm going to use gray. Check in the third sentence. The third sentence is if you double the width, so 2 times 9 would be 18, and increase it by the length. And we never figured out what the length was. So if the width is 9 meters, 3 times is going to be 27 meters. So let's go back now. We double the width to 18, increase it by the length. That means add the length. Then they said the result would be 45. Let's check. 8 and 7 is 15. Carry the 1. That's going to be 45. So it makes sense. Everything we did makes sense, and it looks right. We're going to answer the final thing with a therefore statement. Therefore, the width is 9 meters, and the length is 27 meters. Example 3 done. Example 4. The smaller of 2 consecutive even integers, I'm going to underline that right now because I know that's going to be important. Even integers is doubled and then added to the larger. When the result of this is divided by 11, then blah, blah. Okay, we are going to be finding the 2 integers. So step 1. Step 1. Go away. Step 1. Let x be the smaller integer. And that's just a number that's not a decimal. And then it said the smaller of 2 consecutive even integers. So x plus 2 is going to be the larger consecutive even. Remember when we did consecutive even? That's like doing 10, 12, 14, right? You add 2 each time. So x plus 2 is going to be the larger integer. Let's write the equation now. So the smaller one is doubled and then added to the larger. So the smaller one doubled, that's going to be 2 times x, or 2x, is added to the larger. Added to the larger. Now the larger one was x plus 2. When the result of this is divided by 11, So the result of this is divided by 11. The answer is -2. So we have this big long thing, and we have our equation. First thing I'm going to do is simplify in the brackets. So it's 3x plus 2, because I'm going to combine the 2x and the positive x. Now I'm going to use algebra to solve. So I'm going to get rid of that time, divide by 11 first, times 11 on both sides. I'm going to get -22 there, and 3x plus 2 over here. I'm going to subtract 2 on both sides. So I get 3x equals -24. Divide that by 3, divide -24 by 3, and I end up with x equals -8. And if we go back to the questions, it said find the two integers. So step 4 over here. Therefore, the two integers are -8, and the next one's going to be -8 plus 2. So that's going to be -6. So if you had any troubles with those questions, go back, watch them again. Your homework is going to be finishing off questions 1 through 11 up to page 17. If you get really stuck, don't forget to go to Homework Club after school, or you can check with Ms. Carr or Mr. Residen.